Pileggi Technical Services, your computers and electronics concierge service.
Welcome back. Well, you can probably guess from the title of the video, we're going to be wiring some LEDs into a jack-o'-lantern. But first, let me start off by saying why we're doing it. You see, my wife's job is having a pumpkin carving contest, and she decided to participate this year, which means I'm going to help her carve a pumpkin. And I decided, well, being the geek that I am, why not step it up a little bit and put some kind of electronics into it. Now, I've been debating about putting, some Arduino-based stuff into it, but it's not something I'm going to really do right now. And it's simply because, well, it's basically less than a week away, and I haven't had enough time to really think about it till now because I have been doing other projects. So it might be a project to work on for the next time, but this will be a basis to start off. But what I have here is some text that I wrote out earlier, basically planning this out. And like I said, the concept's to build a LED based light for illuminating a jack-o'-lantern. We need several parts for this. Obviously LEDs, the resistors to limit the current to those LEDs, PCB board to mount them, batteries to power them, a switch to turn them on and off, and obviously wiring. And then I have some ideas like where am I going to put them. I could put it from the lid, I could put it from the bottom. I think the lid's going to be the best way, it's going to hide it the most. Again, the Arduino control question, but I'm not going to do that. How many LEDs? Well, that depends on how big the pumpkin is and how bright they are, the whole 9 yards, and also depends on what color. I've gotten that question answered already. And then of course the question is what design to carve. Well, this video isn't about the carving of the pumpkin. This is just about the geek stuff, and that is the LED part, obviously. So we're going to get onto that, and then what I'll do is I'll have the pumpkin carved once the wife and I figure out which pattern to go with, and then we'll figure out how the lights get mounted into it from there. But this is going to be, the rest of the video is just the LED unit. But the LED specs that I have after going through my parts bin is I have a bunch of red and I have a bunch of green LEDs. Now I think I'm going to go with the green ones. They draw a little bit more power. Actually, the current is the same, but they draw a little bit more voltage. So that means that you use a different resistor. Now I have the values, the known values for a 5 and a 12 volt configuration, which is what those resistors actually came with. But the system that we're going to use, we're not going to put a resistor per LED. That's inefficient. I actually went onto the LED resistor calculator wizard that you can go on. I'll put a link in the description. That will give you the data for one resistor and also gives it to you in series. So I'll show you where I'm going to get to with that. Now for battery pack, I do have that one right there, and that is 6 1.5 volt AA batteries, giving you 9 volts total. That's better than using a singular 9 volt battery because you get more current out of it. There's anywhere from 1800 to 2600 milliamp hours per battery in a regular AA battery, and this is with a 50 milliamp draw. Now my 8 LEDs that I figured out I'd use, green by the way, we need 4 150 ohm quarter watt resistors. Each resistor will dissipate 60 milliwatts of power. That's 240 milliwatts total dissipation for the resistors. At the 20 milliamps we're going to run these LEDs at, they'll actually draw up to 30, but I'm going to run them a little lower. We'll draw 512 milliwatts total. That gives you 752 total milliwatts for the entire array, which is 80 milliamps of current out of those batteries. Now, judging by the 1800 to 2600 milliamp hour battery, that's a pretty good draw, I think. I mean, that's going to last for definitely, the whole night. My wife's going to have it at work. The whole day it'll be there. Plus, we'll take it home for Halloween, and it'll last the whole night easily. So that's pretty neat. So I went ahead and, since we're working with LEDs, I went ahead and showed you a little diagram here. Now, I'll show you one up close, but to determine the polarity, when you take one out of the bag, the longer lead is going to be your anode, which is your positive, and the negative is the shorter lead. You can also tell by looking at it because there's a little flag, which they call it. Some people call it an anvil. There's all different names for it, but there's a flat spot too, and that indicates the negative side of it. And here's my schematic, what we're going to do. So we're coming from the 9-volt source to a switch, and then we're going to do 2 LEDs in series with a resistor on the negative side. Or you could do on the positive side, doesn't really matter where. As long as it's, we keep it all the same here. And then we have the ground wire. And then this is actually a series parallel connection. They're in series going this way, and they're in parallel going this way. And then that'll be the hole in the diode array right there. So the way I want to try to design this is with some kind of corner or side facing LEDs that we can have long leads on that'll be able to bend and kind of like angle into different directions. And then I want 4 in the middle to kind of shine straight down. Also, since we're speaking about design here, when you look at the schematic, the way it's drawn out, this is your positive side and this is your negative side. So on the schematic you can see all the positives over here, and think of it like that line points to the negative side, and that's the way diodes are drawn, and light emitting diodes have these little arrows to indicate the light coming off of it. And also when you look on a PCB where it's been pre-printed, you'll see that the silk screen will have a flat spot on one side to indicate the negative side of that LED. So I'll show you what I mean by all that. If you look, here's the longer lead, so that's your positive, that's the anode. And if I get up close, you can see that anvil kind of like funnel looking thing on top. That's the actual piece that emits the light. You can see that dot in the middle. That's called the flag. And I'm not sure if you'll be able to pick up the flat spot. Yeah, actually you can. Right here is that flat spot. You can, if you feel around it, you can feel it's totally flat right here. You can see it up against my finger. The rest of it is rounded out, and right here it's kind of flat. And I have one of these LED testers. This is basically just a 9-volt battery with a little breadboard inside of it, and this will test the Piranha style LEDs, and then also test these 9mm, or I'm sorry, the 5mm or 3mm, or even a big 10mm. And here's your little diagram over here to show you where the positive and negative goes. And I have this right here at 20 milliamp. I mean, this thing will run all the way down at low amperage if I want, but for the maximum brightness you want to run it up here. You see it's really bright. It's gonna provide a light inside that thing. And then here's just one of these battery packs. Now this does have one of those 9-volt snaps on top, so you could use a regular 9-volt in its place. I'm gonna try to see how I'm gonna mount this. It's a little weighty. Hopefully I could actually mount the circuit board right to the side of this, so I could just mount this from the ceiling somehow, at the top of the pumpkin, maybe from the side, and then have the thing down on the bottom with the lights coming out in all different directions. Or we'll have to see how I'm going to do that. And then this is just a pack of LEDs. This was actually cut in half. It's much longer. I just folded it that way because it fits into my pack easier. And that's all I have out right now, so I'm going to go ahead and get started with this, and I'll skip the boring bits and we'll get back when I have something interesting. When designing these projects, it's always best to go ahead and build it on a breadboard first and actually test it out. And what I actually did was just set the meter to amperage here, and you can see we're running at 62.3 milliamps, which is even less than the original 80 milliamps that I quoted myself. So that's great. And you can see all 4 of them are glowing really brightly. If I shut my main light off over here, you see that's a lot of green light. So those spread out facing downward inside of that pumpkin is going to really light it up nice, I think. So I'm going to get the PCB figured out and we'll go from there.
And here's what I got so far. This is a PCB board that's snappable. It's actually double wide. I snapped it in half. I could snap it again, but I wanted this to have a wide footprint. And what I did was, you can see this is actually optimized for ICs and stuff, because a lot of these are actually joined, as you can tell by this rectangular box that's around them. They're connected internally. This is actually double-sided, so they're connected internally, on both sides in multiple layers too, because that's just how they did on these boards. So these vias are actually pretty deep. This is great to work with for new stuff, but desoldering things can be kind of iffy sometimes because of the multiple layers. But alas, it works well for what I need to do. So what I did was I put one of the resistors across these leads, so I just had to connect this to a positive rail, and then it goes from here to the positive of the LED, then that jumps to the pad next to it, and then I'd connect the next negative here, or the next positive here of the next LED, but it doesn't have to go necessarily here. I could jump it over to another pad. So I just basically have the basis starting points of the circuit between the 4 resistors. I do have to figure out which one of these I want to make positive and negative. There's actually this entire rail. If you look like this L piece here and this L here, they're not connected in the middle because this is a break point. So I could make one of these positive, one negative right next to each other. Well, I'll figure that out when I get to it. But right now this is a good starting point with these angled out ones. So this will sit in the top and they'll angle out sideways. Also the battery, I could mount this actually in the middle here, so it takes up the least amount of room, or maybe even sideways like that. Actually, that's a pretty good way to go. So I might just mount these LEDs along the sides here and just have them all coming down, and just leave this like this in the middle.
And here we have the project as far as I can go, because I don't have the pumpkin carved. I went ahead and did a couple of my typical mods here, which I'll show you. We have heat shrink tubing covering the wire going to the battery, just to keep that nice. There was a hole already in this PCB. I just went ahead and enlarged it a little bit so I can pass the wire through here and then solder it. So this is actually a bit of a strain relief. The jumper connections are both on the front and the back, because this is a two-sided board. I decided to make this piece up here and this piece down here the ground, and I connected them underneath with this solid black wire. The battery comes over here and that connects, so the 3 places here and here, actually 2 places I should say, are the only places that are ground. This middle place here is the positive connection, so the battery comes out over here, it stops, because on the other side is the connections for the switch, and this goes right up to the switch and right back down to the connection next to it, and then it jumps over. So you're basically, these 2 pins right here and here are jumping these 2 red wires together, so the current will flow through to the red side here, and then it will power this whole strip. And then this strip divides off on the other side. Over here in the front where it's close, it just jumps over using just a piece of snipped resistor lead. That just jumps over to both sides here to the resistor. There's one resistor underneath the switch here. See if I can get up closer. It's better. And the yeah, so the 2 resistors here are connected just straight across, and then they go up on this side. It's the same on both sides, by the way. It goes over to this resistor, to the positive lead of this LED. From here it jumps over to the next pad, which goes up to this LED, and you can see there's a little jumper wire down here to connect them in between, because like I said, it jumps over a set of pads. Then that's the negative of the LED string. This is also the negative of this LED string, so the 2 positives are at the ends with the negatives in the middle. Then the negative has a jumper wire that goes between the bottoms of the LEDs to this strip, and then like I said, the strips are connected in the back with the vertical piece of jumper here. Then I mounted the switch, and the way that's mounted, I just took some of this wire. I actually bought this in the dollar store. You can get 3 of these in a package for $1. I don't remember what gauge it is, but this is very, very useful wire. Very well worth $1. In fact, I'd pay $1 a thing for it, or a bundle, because it's that worth it. But anyway, I just cut 3 pieces of it. I have one of them over the neck of the switch, and then the other 2 over the back, and then they're pulled in tight. And what I did was I brought them out the bottom using my twisters. I twisted them really tight, so there was a lot of tension on it, and then I soldered them in place and cut the knots basically. I tied in it. So yeah, that's very sturdy, very mechanically sturdy, and it's also, like I said, it's soldered in. If I wanted to, I can actually heat this case up and solder this piece directly to it, but I'm not going to go through the trouble. Now I mounted that switch sideways like that because I was figuring I could just mount this like there. So there's a couple different ways. And just set it like that. You can still actually access most of the batteries. Or I could put it like this and put it on the other side. I haven't really decided yet because, like I said, I don't have the pumpkin. Once I have that cut, it'll make it a lot easier. I may just, you know, drill a hole in the pumpkin and mount this on the top of it. Who knows? It might make it look cool, depending on what kind of pumpkin I'm going to carve. But once, as you can see, you flip the switch, it comes out and makes this pattern. Just shut this light off over here. You can see it's kind of a. I kind of have them aimed like that for a reason. If I make this like a skull, I can actually point these to like the teeth or something. Like, I don't know. I have to see what kind of pumpkin we carve. But this is basically the beginning of it. We'll see what comes next of it once we get the design. There'll probably be a follow-up video. I wanted to actually put something out before Halloween so you get an idea how to do something. And that way if there's any questions or anything like that, hopefully I can answer them before it comes up if you wanted to build one of these or you want me to make one quickly. But yeah. This makes it nice and easy with that switch because you just have to turn it on and off. You don't have to worry about disconnecting the battery. There was a couple different things I was going to try to do. One of them was I was going to pass the leads through these holes on this battery pack. I don't know if you can see it. Yeah, there's two holes right there. And they come out on the other side. So then that way the wire would take up less space. But you can just disconnect the battery, but you couldn't actually take the battery pack off. Ultimately, this, you know, has to be protected from the juices of the pumpkin, which I'm going to try to preserve. So what I'm going to do is I'm going to paint the back of this board and possibly the other side of the board too with that liquid electrical tape that I've been using. This stuff smells, so I'm going to turn my fan back on when I do that. And I'll show you what that looks like when that dries. It takes a few minutes. And here's the end result with the rubber coating on it from the electrical tape paint. You can see how that actually seeped into a lot of the holes. There are a couple coats on here, and this stuff wants to just kind of clump up on its own and go in its own places. So I wouldn't say it's completely submergible waterproof, but it was definitely going to hold up inside this pumpkin for days and nights to come for sure. Well, that's all I have for this video. I want to thank you for watching, and stay tuned for the follow-up video when I get this thing mounted inside the pumpkin and you can see it all lit up. Welcome back. As promised, here's the carved pumpkin. Not sure if you could make it out in the camera or not with the level of light that I have in the room, but it's a couple of ghosts, or my wife says they look like ETs, but it's a couple of ghosts holding hands and embracing, getting ready to maybe kiss or laughing or whatever they're doing, but they're silhouetting against what looks like a skull. I think you can kind of see that. Maybe if I could turn it more towards the light. And what do we have inside? Oh, hello. Now you can see the little switch. I can turn this on without breaking anything. There they are. I've angled them a little differently than I originally had them, but let's see if we kill this light. Ooh, spooky. Thanks for watching.